gonna do another question, which is write the dimension, the dimensions of the dimensional variable omega and k in the following equation: y equals to a sine omega t minus kx, where t and x are time and distance respectively. So here we have no information about y, a, omega and k. We don't know what they are, which means and we have to find omega and k. Since omega and k are to be found, and since y and a are not given, it means that y and a are not significant when finding the dimension of omega and k in this case. So when doing this, first of all, let's write the equation which we are given, which is y equals to a sine omega t minus kx. So this is the equation that we require, and the dimension of the things that we were given, which is time, it will be t, and the dimension of x, which is the distance, will be L, right? So now sine sine omega t minus kx, sine omega t minus kx is dimensionless, hence hence from the principle, so let's write this in so hence from the principle of homogeneity, omega t minus kx as a whole is dimensionless, so let's move this up, is dimensionless. And again, from principle of homogeneity, omega t and kx are dimensionless as well. It's not that omega or t are dimensionless, it's that omega t as a whole is dimensionless. This part as a whole is dimensionless. So now since omega t is dimensionless, this must be dimensionless, which will be m to the power 0, l to the power 0, t to the power 0. So here we need to find the dimension of omega. The dimension of t is t, so here m0, l0, t0. So the dimension of omega is per time. Pretty simple, right? So now let's find of k, which we need to find as well. So the dimension of kx is again dimensionless, which will be m0, l0, t0. So the dimension of k is to be found. The dimension of x is L. So we have m raised to the power of 0, L raised to the power of 0, t0. So we have k to be equal to L minus 1. So hence the dimension of omega and k are per time and per length respectively. So this was the question and we did it. But if the question asks the relation between omega and k, so there are two ways to ask the question, which I'll show you. So if they ask, you do it like this: since by the principle of homogeneity, the dimension of omega t must be equal to the dimension of kx, since they are subtracted. So let's see, since they are subtracted, this must have the same dimension as this in order to be subtracted. So now we know that the dimension of omega, we don't know the dimension of omega, don't know the dimension of k, we know the dimension of t, which is t, and the dimension of x, which is L. So there are two ways to go from here. The question can ask the dimension of omega over k, so the dimension of this, which will be, so you can do the math, it will be lt minus 1. It is the same as the dimension of velocity. So the question can also be asked that the dimension of omega over k is the same as the dimension of, and you must say it is the same as the dimension of velocity or something equivalent. Another way is k by omega. So k by omega will leave us with L minus 1 t to the power 1. So these are the two ways that the question can be further asked. And with this, it is the end of our video today. So in the next video, we are going to do a theoretical question. Till then, bye.